Hi, good morning one and all. My name is Mudawat Lakshman and I am from Computer Science of Engineering Department. Today I am going to discuss about the topic double hashing sort algorithm from the subject design and analysis of algorithm. Now we are going to discuss the introduction of double hashing sort. So sorting algorithms are fundamental in computer science for organizing data efficiently. With increasing data sizes, the need for faster and more efficient sorting techniques has become critical. Double hashing sort is a novel approach that leverages hashing principle to improve sorting performances. So sorting algorithms are one of the core topics in computer science because they help organize data efficiently for faster searching and processing. As the data is increases in modern applications, traditional comparisons-based sorting algorithms may become less efficient. To overcome these challenges, new hybrid techniques have been proposed. Double hashing sort is one of such approaches that combines the principle of hashing with sorting logic. By using hash functions to estimate positions and resolve conflicts, this algorithm aims to improve sorting efficiency, especially for large data sets. And now, what is double hashing sort? Double hashing sort is a hybrid algorithm that combines hashing techniques and sorting logic to efficiently organize data. It uses two hash functions to estimate and refine the position of each element in a sorted structure. The first hash function analyzes the distribution of data, while the second resolves collisions and ensures accurate placements. So now double hashing sort is a hybrid sorting algorithm that integrates hashing techniques with sorting mechanisms. It uses two different hash functions to determine the correct position of each element in sorted structure. The first hash function provides an approximate location based on the data distribution, while the second hash function resolves collision by determining a probing step size. We know there are open hashing and closed hashing, and in open hashing we have in closed hashing we have linear probing, secondary probing, and double hashing, all these things. So we use it in a hashing in Java, Python, or in a DSA. This two-level hashing approach reduces clustering and improves placement accuracy. So we have to place a data element to retrieve it, to resulting in faster and more organized sorting. So first, what is hashing and what are the basics? What are the basics of hashing? Hashing technique is a hashing technique to map data to a fixed size table using hash functions. Collisions occur when multiple elements map to the same index. Resolution strategies include linear probing, quadratic probing, and double hashing. So here, hashing is a technique used to map data elements to specific positions in a fixed size table using hash function. Since different elements can map to the same index, collisions may occur. Common resolution techniques include linear probing, quadratic probing, and double hashing. Double hashing uses a second hash function to compute the step size for probing, which significantly reduces clustering and improves data distribution. These hashing concepts form the foundation of the double hashing sort algorithm. And here we can see hashing uses. In an image, hashing are uses for password security, password verification, tokenization, blockchain, structure, and compilers in programming languages data. So these are the uses of hashing functions, and hashing in the data structures and algorithms are data analysis and algorithms. So now go for how it works, how the hashing is works. So initial distribution will be done. So that's hash function 1. Each element is passed through a primary hash function. Example, we can say hash function 1 x equal to x modulus n to determine its initial bucket or index. These steps helps gather distribution statistics, how data is spread across the range. So that is, in first step, each element is passed through a primary hash function such as let's take example h1 of x equal to x modulo n to determine its initial bucket or index. This phase does not directly sort the elements, but instead helps analyze how data is distributed across the range. And using here index estimation, using cumulative distribution, the algorithm estimates where each element should ideally be placed in a final sorted array. This phase mimics the behavior of counting sort, but uses hashing to guide placement. Here, using this distribution information, the algorithm estimates where each element should ideally be placed in a final sorted array. This step is similar to counting sort, but uses hashing to guide position estimate. And in collision resolution, that is hash function 2, we can say if multiple element map the same index, a second hash function, example h2 of x equal to 1 plus x modulo m, determines the step size for probing. This avoids clustering and spreads elements more evenly, improving performance. Here in the first step, each element is passed through a primary hash function such as h1 of x modulo n, but here when multiple elements are mapped at the same index, collision occur. To resolve this collision, a second hash function such as h2 of x equal to 1 plus x modulo m is applied. This function determines the step size for probing alternative positions. By using double hashing, the algorithm avoids clustering and ensures a more even spread of elements. Finally, each element is placed into its estimated position while resolving conflicts efficiently, producing a sorted array with a minimal overhead. And finally, we have to placement, right? So finally, each element is placed into an estimated position. Here, each element is inserted into an estimated position, resolving conflicts using double hashing. The result is sorted array with minimal overhead and fast access. Next, what is the process summary of this? Or we can say here we have some flowchart of the hashing sort. Okay, the double hashing sort algorithm distributes data, builds an index array and sorts elements iteratively. It checks if all elements are sorted repeatedly the process if needed. Until completion, this ensures efficient structured sorting using hashing and indexing techniques. Here we can see the flowchart. It starts and it again perform initial distribution, again build indexing array, sort the data elements, and if the elements are there, it goes to the end. All elements are sorted. It checks for yes or no if condition. If yes, it goes for end, or no, and then it goes again and all elements are sorted or not. So how this is how it works. From hashing to sorting. Double hashing sort adapts the double hashing technique to sorting by using the first hash to gather distribution statistics and second to determine the final sorted position of each element. Double hashing uses two distinct functions. The first determines the initial position while the second provides the step size for probing. This reduces clustering and improves distribution. Here, double hashing sort adapts the traditional double hashing collision resolution technique for sorting purposes. The first hash function determines an approximate position based on value distribution, while the second hash function decides how far to move when collision occurs. This approach significantly reduces the clustering, which is a major drawback in simple probing methods. As a result, elements are distributed more evenly, leading to improved sorting performances. So this is from hashing to sorting. So there will be a distributed function and there will be a placement function, and then at last it places into the sorting algorithm, sorted array. And now we move to the algorithm phases. What are the algorithm phases? Distribution statistic collection. Analyze data distribution using the first hash. The algorithm operates in three main phases. First is distribution statistics are collected using the primary hash function to analyze how elements are spread. And second, we have indexing phase. What is indexing phase? Estimate final positions using cumulative distribution. Here, the second one, an indexing phase estimates the final position of elements using cumulative distribution data. In the third, we have sorting phase. Place elements using second hash to resolve conflicts. So the third one, the sorting phase places elements into estimated positions while resolving collisions using the second hash function. These well-defined phases ensure systematic and efficient sorting. Now we go for the time complexity analysis. What is the time complexity analysis for the double hashing sort? In the best case, we have uniform distribution. Each element is placed directly into its estimated position with minimal collisions. The complexity is order of n, since each element is processed once. In the best case, when the data is uniformly distributed, each element is placed directly into its estimated position with a minimal or no collisions. In this scenario, the time complexity is order of n, as each element is processed once. In the average case, performance depends on the quality of the hash functions. With well-designed hash functions, collisions are rare. and probing is minimal, resulting in near linear time complexity close to order of n. And what about the space complexity of this double hashing algorithm? So space complexity of this is hash table storage requires an auxiliary hash table of size proportional to the input array, and complexity is order of n. So here double hashing set requires additional memory to store hash tables and indexing structure. The hash table size is proportional to the number of input elements, resulting in order of n space complexity. We have additional structures, that is distribution statistics and indexing arrays also scale with input size. Complexity is order of n. So we got here additional arrays for distribution statistics and indexing also grow linearly with the input size, and therefore the overall space complexity of algorithm is order of n, since all extra structure grow linearly with the number of elements, making it suitable for applications where extra memory is acceptable. And comparison with other algorithms, if we compare these double hashing sort with quicksort, medsort and heap sort, we got a different time complexities. Here we got order of n for double hashing sort, and for quicksort the time complexity is order of n log n, and as same for the medsort and the heap sort also. The space complexity here for the double hashing we have order of n, and for quicksort it is log n, and for medsort and heap sort it is order of n and order of 1 for the heap sort. And the stability of these algorithms, for the stability is no. For double hashing sort there is no stability, and for quicksort also there is no stability. Only for the medsort here we have the stability, and as well as the heap sort it doesn't stable. And next we go through the example walkthrough. So here we have a given array. We got the elements 23, 45, 12, 67 and 34. Here consider the array 23, 45, 12, 67 and 34. The first primary hash function is applied to each element to determine distribution. Based on these values we have some steps. There will be a step 1, apply first hash function, and then we have the step 2 is distribution. The step 3 is estimate position using cumulative distribution, and step 4 apply second hash, and step 5 resolve collisions and place elements. So here the first one is the primary hash function is applied to each element to determine distribution. Based on these values cumulative distribution is calculated to estimate final positions. Next, the second hash function is used to resolve collisions and probe alternate positions if required. Through this step-by-step placement the array becomes sorted efficiently using hashing technique. This double hashing algorithm is efficient for large data sets and reduces clustering, fast insertion and lookup, good for real-time systems. So here, especially when data is uniformly distributed, it is advantage that efficient for large data sets. That double hashing sort is efficient for large data sets, particularly when the data is uniformly distributed. The use of two hash functions reduces clustering and improves data spread. Hash-based placements enables faster insertion and lookup compared to comparison-based sorting. Due to its predictability and speed, the algorithm is suitable for real-time and performance-critical systems. So now it's about limitations of this sorting algorithm. The limitations are require two good hash functions and more complex than traditional sorts. Performance depends on hash function and not suitable for all data types. So the limitations are, despite its advantages, double hashing sort has become limitations. It requires two well-designed hash functions to perform efficiently. The algorithm is more complex than traditional sorting methods, making implementation harder. Performance is highly dependent on the quality of hash function, and it may not suitable for all data types or uniform data sets. These are the limitations of these double hashing sort algorithm. And now we go for the references. And the references are several research works and academic sources support the effectiveness of double hashing sort. Studies have shown that it can outperform quicksort by 10 to 25% in specific scenarios. IEEE research articles and standard textbooks on data structures and algorithms provide further theoretical and practical insights into hybrid hashing based sorting methods. So here Azim M. Bahim 2019. So In the 2019, he researched about the complexity, analysis, and performance of double hashing sort algorithm. Journal of Egypt. He is a Journal of Egyptian Mathematical Society, and it's in volume 27 and article 3 demonstrates the double hashing sort can outperform quick sort by 10 to 25% in certain cases. And by the basis of IEEE Explore 2023 double hashing sort algorithm. So it says that research articles explore hybrid hashing sort methods to improve time and space complexity. And from textbook references, data structures and algorithm in Python, that's by Wiley. So next it's about conclusion. So double hashing sort is a powerful hybrid algorithm that combines hashing and sorting principle to achieve efficient data organization by reducing clustering and minimizing comparisons. It provides near linear performance under favorable conditions, although it has certain limitations. It is a valuable approach for large scale performance sensitive application. So this is all about this sorting algorithm.